Okay, so in this video we are looking at probability, basically the introduction portion for Algebra 2. It keeps it mostly simple and just make sure you understand what probability is and kind of what an outcome is. And this is kind of where we're moving after wrapping up kind of what we needed to touch on in terms of sine and cosine graphs. So that was the last thing we talked about. I will say to make sure this video makes it to more people, or hopefully, if you watch this and learn something, please hit the like button. I'm now a stereotypical YouTuber, so there's that for you. Trying to get to 200 subs. Maybe we'll add some gameplay videos once we get to there. Seems split on if we actually want that, but I think it would be fun to do, so we'll probably end up doing that. Okay, to get into this introduction to probability, IXL, let's run through the whole thing maybe a little bit more than one time through. So on the first run through up to around 70 of a SMART score, we'll hit every problem. After that we might do a couple additional ones and probably go a little bit quicker on those. I suggest if you are working on this for my class, you have this video pulled up kind of as you're going through. Okay, number one. Can 0.38 be the probability of an outcome in a sample space? There's a lot of kind of specific math jargon being thrown at you, like math-specific words. Basically what this is asking is this number, 0.38, allowed to be used for probability. So probability needs to fall between 0 and 1. So as long as this number is between 0 and 1, which it is, it can be an outcome. If it was bigger than 1 or if it was negative or something like that, it would be no. So as long as it is between 0 and 1. So this one would be an example of something like that. Again, this is above 0, so it's greater than 0 because there is some value, but there's no whole number here. It's less than 1. So again, this would be yes. I have had some, I guess, suggestion to do more examples. However, these ones are going to seem a little bit repetitive, so we might go quick on this part and maybe a little bit slower on the next part to make up for that. Can negative 0.62 be the probability of an outcome in this sample space? Sample space is basically like whatever you are taking the probability of whatever you're like testing. It doesn't really apply much in this instance. That would be more if you had some like real life thing that you were taking a sample of, I guess, if you were surveying actual people based on something. All right, this one is negative, so therefore it is not above 0. It is below 0, so this is a no. Okay, so I'm glad that we hit these back to back. 35.05, well 35 in general is above 1, so that again would throw it out. Think about that 0 to 1 being like 0% to 100%. Has to be between there as a probability. This would be like, I don't know, like 3,500% or something like that. And then a little bit more. So this would be no. Okay, so this is where we start to change a little bit. Does the table, so this, show the values of a valid probability function on the outcomes in a sample space? So basically, are these like options here valid? Are they usable? We said that probability has to be between 0 and 1. So there's like I said, between 0 and 1 is like 0% to 100%. And that also means all these different outcomes. So let's say you're flipping a coin. That's usually a pretty standard like probability example. Let's not think about the option of the coin landing straight up for a second. But if you flip a coin, there's pretty much a 50 chance it lands on heads, a 50% chance it lands on tails, and that total percentage there is 100%. So all the probability needs to add up to 100%, or if it's represented as a decimal like this, needs to add up to 1. Think about like a normal die roll, like if you rolled a dice. There's 6 options there. Each option has, it would be like 16.66 repeating percent to happen, or if it was in this form, it would be, maybe I can type that on here, it would be like 0.16 repeating. I can't do the repeating bar. Or here, I'll do this. We would have this 6 times, and if you added that up, this plus itself 6 times, it would get you to that full 1. So that's kind of what we're looking for. So these are 3 different outcomes of something. They don't tell us if we're rolling a lopsided die or whatever it is. Something's happening. There's about a 0.3 probability of this happening, a 0.5 probability of the second thing happening, and a 0.1 of the final thing. I would want to add those up. So I would think like 0.3 plus 0.5 plus 0.1. And if those add up to 1, it's valid, and anything else would be invalid. So this is where I'm getting like a calculator out and I'm typing them in, and I'm seeing they equal 0.9. So that automatically tells me that is not 1, therefore this is invalid. So we would say no. Another table 1, and it's asking the same thing. Do these add up to 1? So I could think about it this way if I want to go faster. 1 plus this 1 would be 2, plus another 2 would be 4, plus another 4 would be 8. So essentially what I just said right there was this, 0.1 plus 0.1 plus 0.2 plus 0.4, all those options. But we just said they equal 0.8. Again, that's not 1, so that's another no, it's not valid answer. Same kind of thing here, and we'll do the multiple different examples. So let's type this out, 0.1. It's the same kind of concept over and over again for this one. I think they get a little bit more tricky in terms of, I think they go like 3 digits for decimals or something like that, but nothing too wild being thrown at you. Can't type and talk at the same time. Did I get all these? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay. Now if I add all those up, I'm looking for 1 in order for it to be a yes. Anything else is a no. You might even be able to hear me clicking on a calculator right now. I'm using my phone though, so we'll see. So these actually do add up to 1 or 1.0. Your calculator might tell you. That tells me this is yes. Notice we've reached an 80. This is where I'm actually only asking for a 70 right now, but that's usually where we would go to. You notice they still haven't really changed. Let's see if we can jump up a level. So around mid-80s, they change to more decimal places. It's the same thing though. So if you're just typing in the calculator, you would add all these up and say either yes it's 1 or no it's not 1. Anything else for us? Let's look at the challenge zone for a second. Okay, same thing except just more decimals. And eventually they go into like 3 digits. So same kind of idea. Let's move on to, this was CC1. Let's move on to CC.2. We're still talking probability. Okay, and we're at the beginning here. Yep, that's 0. Okay, so this one says calculate probabilities of events. So events are like when we flip a coin or something like that. That is the event, the flipping or the rolling of a die or anything like that. This is where if I was in class, I would take the giant die that I have sitting on my table or on my like cabinet and throw it across the room multiple times. It's not completely even though, so it would kind of mess up some of this. Okay, this one says the table gives a set of outcomes and their probabilities. Let A be the event. The outcome is less than 3. find, when I see this, all that does is it reads the probability of A, and we know A is the outcome is less than 3. So really what this is saying in this case is find the probability of, is the parentheses, the outcome is less than 3. So if we look at our options here, well, let's start at the top, I guess. 1 is less than 3, so we're going to use this one. 2, that's less than 3, so we're going to use that. However, 3 is not less than 3, they're equal, so we're not going to use this one. So we're going to add just these two things together. If we were using this, we'd also add that in. So what we need to think about, we could go back to the calculator if need be, is 0.4 plus 0.4. That would give me 0.8. So that's what I'm going to give here, rather than a like yes or no. 0.8. Awesome. Okay. The table gives a set of outcomes or probabilities. This time we're looking for the probability of outcome less than 4. So similar to the last one. 1 is less than 4. 2 is less than 4. 3 is less than 4. Similar to the last one with the 3. 4 is not less than 4. They're equal, so we're not going to count that one. So now these get added together. So what we would do is we would do 0.2 plus 0.3 plus 0.1. I would probably type that in the calculator, and I would get 0.6, and that's what goes in your kind of answer box down here. Okay, they're going to ask essentially the same thing with different events happening. So this time, the outcome is greater than or equal to 4. 1 is not greater than or equal to 4, so not that one. 2 is not greater or equal to 4. 3 is not greater than or equal to 4. 4 is not greater, but it is equal, so we're going to use this one. We don't even have to do any addition right here. That's the only thing. We just type that in, 0.2. Okay. Table gives an outcome. Okay, same thing. Probability that the outcome is a divisor of 4. So thinking about our math terms, basically what that means is can we do, what's a good way to put this? Can we do 4 divided by that thing and get a whole number back? So for example, we can do 4 divided by 1 and we get a whole number back. We get 4. If we do 4 divided by 2, we get 2 back. If we do 4 divided by 3, that's not going to work because it's going to give us a decimal. 4 divided by 4 is 1. All these are bigger than 4. They're not going to work. This would give me a decimal. 4 divided by this would give me a decimal. 4 divided by that would give me a decimal. So I'm just using these right here. And I'm going to add those together. We're getting into an extra digit here, so we might, if you weren't before, you might want to use a calculator. We're doing 0.13, 0.44, and 0.02, and get 0.59. One of my bigger suggestions is we are going to see in our question divisor and divisible by. You might want to have this open as you're working through yours to tell the difference, because even I get mixed up and I kind of flip back and forth in my head. Okay, so divisor of 7, so this is similar to the last one, basically asking can we do 7 divided by that thing and get a whole number back. 7 divided by 1 is still 7. 7 divided by 2 is a decimal. This would give you a decimal, this would give you a decimal, this would. 7 divided by 7 is 1, that works. 7 is prime. That's kind of another way. If you have a good grasp on that, you could think about, okay, it has to be only these two. So then it would just be those that get added together. So I would do 0.06 and 0.23, and I would get 0.29 and put that in here. Okay, divisor of 6. 6 divided by 1 gives me 6. 6 divided by 2 gives me 3. 6 divided by 3 gives me 2. 6 divided by 4 gives me a decimal. 6 divided by 5 gives me a decimal. 6 divided by 6 is 1. This would give me a decimal. So it's these three, and then also this one. All get added together. At this point, you might have a pretty good grasp on it, but if not, we're going to keep working through, and you can skip ahead if you need to. I'm going to type all these in, so 0.13, 0.05, 0.07, 0.09. And I get 0.34. My past math teachers would be mad at me for not using tenths and hundredths and thousandths instead of saying point, but I think it works for what we're doing here. The outcome is a divisor of 6. Okay, so this is pretty similar to what we had just a second ago. 6 divided by 1 is 6. 6 divided by 2 is 3. 6 divided by 3 is 2. 6 divided by 6 is 1. All these are bigger than 6, so they have to give us a decimal. So we're adding these together. So if I type that in, I will caution you to be careful. It's 0.01. I just messed that up for a second, so I skipped that 0. Okay, and this adds up to 0.15. Divisor of 7. So we already had this one, so that's why I'm going a little bit quicker. The only thing that divides 7 divided by that thing gives you a whole number are these two. 0.03 and 0.05 would give me 0.08. Let's see what else we have. Man, I'm getting a bunch of these divisor ones. I actually ran through this IXL a second ago and I didn't get any, so it just shows you it could be anything. If I don't get the divisible option, I'll go back through until we find one so you have an example. Divisor of 3. 3 divided by 1 gives you 3. 3 divided by 3 gives you 1. All these are bigger than 3, so they're all going to give me decimals. If I add those together, 24 and 3 would give you 27. So 0.27. Divisor of 9. 9 divided by 1 is 9. 9 divided by 3 is 3. 9 divided by 9 is 1. So you have these options. Hopefully the divisor aspect of it makes sense what that means. I think after a couple it should, but maybe right off the bat it didn't. So 0.04, 0.03, 0.01 gives me 0.08. Okay, so we're kind of changing it up. Less than 6. So less than 6, that's going to be basically everything on the table that comes before it. So all these get added together. You notice we're getting into an extra digit again, so I suggest a calculator. I mean, obviously you don't have to, but play it safe. I'm getting 0.33 when I add all those together in my calculator, so let's see. Awesome. Oh, here's a divisible example. Okay, so divisible by 8 is kind of the other way around. We have to be able to divide that thing by 8 and get a whole number back. So if we go down our list, 1 divided by 8 gives me a decimal. 2 divided by 8 gives me a decimal. 3 divided by 8 is a decimal, 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 decimal. 8 divided by 8 is 1. 9 divided by 8 is a decimal, 10 divided by 8 is a decimal. So it's only this one right here. When you only have one option like this, you don't have to do any addition. It's just that probability. So that works out nice for us. Okay, we're past that 70 mark. Let's jump ahead and see if anything changes, just in case. Okay, so let A be less than 5, let B, so there's a second event now. Outcome is less than or equal to 2, and the probability that when it says or, just one of those things has to happen. I didn't go through these beforehand, so let's make sure I'm doing it right for you guys. If not, this will be a good learning experience. So let's make sure all these outcomes fit into one of those categories. So let's think about 1. Is it less than 5 or less than or equal to 2? It's actually both. 2 actually falls into both categories. It's less than 5 and equal to 2. 3 is still fine because it's less than 5. It doesn't work for this one, but it says or, so it only has to do one or the other. 4 is less than 5. 5 doesn't work for either because this says less than 5, not equal to. And this is less than or equal to 2, so it definitely doesn't work there. So then all these would get added together. So this part doesn't change from what you were doing a little bit ago. You're just adding. And we would get 0.74 for our total. All right, brilliant, awesome. Okay, so that is what we're looking for there. This is past where you guys need to go, but we can still talk about it. We'll do at least one more. The outcome is less than 3, and we want to find the probability that it's not this thing. So basically, which ones don't work is what we're adding together. So we want to find which things are essentially not less than 3. 3 is not less than 3. 4 is not less than 3. 5 is not less than 3. 6 is not less than 3. 7 is not less than 3. So basically all these. Another way is to find what does work and subtract it from 1. So a couple options there. If I add these together, we're looking at 0.76. And that makes sense because if you added these two, it'd be 2, 4, and together those give you 1. Awesome. Not A, that's the same thing. Okay, let's go back and find one more divisible one. Oh, perfect. Because we only spent one question like that. Divisible by 6 basically means some number divided by 6 needs to give you a whole thing back for it to work, for it to be divisible. So 1 divided by 6 is not a whole number. 2 divided by 6 is not whole. This doesn't work. None of these work. 6 divided by 6 is 1. Then those don't work either. So again, if you only have one option, it's just right there. So I'm not sitting here searching. Let's actually just talk about one. It won't take it as a correct answer, but just in case you guys see it. Let's say instead of 8, that was like a 2. Divisible by 2 means something divided by 2 gives you a whole number back for it to be divisible. So we would go down the list. 2 divided by 2 gives you 1. 4 divided by 2 gives you 2. This would give you 3. That would give you 4. So all those would be divisible by 2. And you would add all those together. Now, I'm not going to actually type that in because it wouldn't count here. That wasn't the right problem. But wanted to give one extra example. I'm trying to get a little bit better at covering all of our bases here. Okay, so that's CC1 and CC2 of intro to what probability is, what it's allowed to be, and then calculating probability based on its event. So kind of what it's saying in the quotes there. All right, hopefully this helped. Again, if it did, please hit the like button. Feel free to share it out. It's mostly for a class at this point, but maybe we can, like I said, play some video games or something like that. I've done some streaming from the PS4, but I don't have a mic yet, so if we do pre-recorded things, I can get that to work. Maybe that'll be fun. All right, hopefully it helped, and thank you.